Good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. Okay, the date for today is April 15, 2024, and the time is what time is it? 1:26 a.m. Okay, my topic this morning will be a long video format. Okay, and it is one of the new long video format topic on my channel. It's the study of analytic geometry. Okay, let's proceed. The title of the subject matter for this morning, for those who are following my channels, it will be analytic geometry, and this will now be lesson number 5. Uh, we are taking it gradually, okay? And the title of the topic will be point slope form of a straight line. I think there should be a dash over here. Point slope form of a straight line. We are on the topic straight line. The last time around, I discussed still the topic straight line, but the last topic involves the so-called if we are given 2 points on a straight line, what will be the required equation? And the second topic, the last time around, is actually if we are given the slope and the y-intercept, what will be the equation of a straight line? So for tonight, or for this morning, we will be deriving the equation of a straight line if we are given the slope and 1 point that lies on the straight line. It is similar to case number 2 from the previous discussion. But the point we are mentioning here on this topic is not the y-intercept. It's another point that lies within the straight line. So it seems case number 2 from the previous discussion is just like similar to this one, but the point indicated are not actually the same. Because the last case number 2 from the last discussion is that the given point is the y-intercept, but for this one, that point is not the y-intercept. It is just designated as point P1 with coordinates x1 and y1. Okay, if we try to bring out a figure to satisfy the point slope form of a straight line, we are given the Cartesian coordinate system. This will be the y-axis. This is the x-axis. So we could draw any straight line. Okay. And from this straight line, we are given point P1. This should be point P1. The coordinates will be x1 and y1. So the point we are mentioning here is actually this point. And how about the next one? The slope is given. So with the given straight line, the slope is actually given. Okay? So the problem is just asking if we are given the slope and we are given the coordinates of a point on the straight line, which is designated as x1 and y1, the problem is just asking what will be the equation of a straight line. Oh, this is an easy one. Don't be bored, guys. We are just on the topic straight line, so when we go to the conic sections, it's a little bit more complicated. Okay, let's try to bring out the derivation. Okay, the derivation of the equation. To derive the equation of the straight line, we will start with the so-called definition of the slope. Because actually, this is the definition of slope. It will be the change and y over the, sorry for that one, change and x. Okay, that's the definition of slope under analytic geometry. it will be the change in y over the change in x. The change in y will be y minus y sub 1 over x minus x sub 1, or this is just a change in the ordinate over the change in abscissa. Because y and y sub 1 are actually ordinates, and x and x sub 1 are actually abscissas. So actually, by definition in general, it's actually the change in ordinate over change in abscissa. So if we are considering point P1 and point P, okay, they should be the straight line. The coordinates of P will be xy, and the coordinate of P1 will be x1, y1. So if we try to get the slope of this, it will be the change in ordinates between P and P1 over the change in abscissa. It is actually represented by y minus y sub 1 over x minus x sub 1. So that's an easy one, okay? And if we try to simplify this one, we will compute for y as a function of x. So if we try to multiply m times this, it will be this one. This one we will transpose to the left, then we'll try to rearrange. So the equation of the so-called point slope form under lesson number 5 will be y equal to y sub 1 times the product of m times the quantity x minus x sub 1. This should be the required equation. It's an easy one. It's just a straight line. It's just linear, you know. Okay, let's try to illustrate the concept of the so-called point slope form under straight line. This is just an easy one. Find the equation of the line that passes through the given points on the straight line is 4 and 3 and has a slope of -3, and sketch the figure. That's an easy one. If we try to bring out the sketch of this one, figure, sketch, we are given the Cartesian coordinate system. They should be y-axis, x-axis. We must have to specify the location of the point of the straight line. The coordinates are actually 4 and 3. So this is 1, 2, 3, 4, right? That's the abscissa. And the ordinate of the point is actually 1, 2, 3. So the intersection of this, that's this one, is actually this one. So the location of the point is actually at this location here. Okay? The slope is -3. Okay? The line should pass here, and since the slope is -3, any slope that is negative, it should slope upwards to the left. Okay, slope upwards to the left. So actually the slope of this one is -3. It's -3, so this is greater than 90 degrees. It's an obtuse angle. Okay, it will be slope upwards to the left because it's negative. Right? So this is the required straight line. Okay? And we are to find for the equation of this straight line. If there is a point on the straight line with the coordinates 4 and 3, and this slope will be -3, and the problem is just asking what will be the equation. Right? So it's an easy one. Again, we start with this one. We could follow this one immediately, or we could start from the definition of slope. Slope, by definition, under the study of analytic geometry, it will be the change in ordinate over the change in x, or the change in y over change in x. So considering P1 and P, okay, this will be the required equation. It is same as this one. Okay. Under this concept, or under this lesson, the slope is given, -3. And we are given point P1 on the line. And the coordinates are actually 4 and 3. So by using this equation, we could solve for the equation. So substituting now, negative 3 equal to y minus 3 over x minus 4. This is plus, so this is minus 3. The operation is subtraction, so it doesn't change, right? And again, the abscissa is also positive. The operation under the denominator is also subtraction, so this is minus 4. If, minus 3 is actually minus 3 over 1, right? So actually, we could cross multiply this one to simplify. So minus 3 times the quantity x minus 4, 1 times y minus 3 is just y minus 3. Expanding the left, this is minus, right? So minus 3 times x will be negative 3x. Minus 4 will be, this is a minus and a minus. We are multiplying two numbers which are both negative, so it will become plus. And the magnitude will be 3 times 4 is 12, and this will now be plus. This is minus 3, we put it on the left, so this will become plus 3, and this should be equal to y. So y now, the equation of the required straight line, we try to rearrange, we put y on the left, all x terms on the right, plus the constants, so this will become minus 3x, and 12 plus 3 will be plus 15. So the equation of the required straight line is actually y equal to negative 3x plus 15. Okay, that's the equation of the straight line using the so-called point-slope form solution. It's an easy one, guys. Okay, for those of you who would like to subscribe to my channel or would like to watch the videos on my channel, okay, my channel is at youtube.com/@ProfDVJ. If you want to share it, please click share. I am assuring you, you will learn something from it. Okay, good morning from Los Angeles, Professor DVJ.